I'm Tomas Mustelin, Professor of Medicine at the University of Washington in Seattle, lifelong immunologist, and happy to answer any questions you have.
What do you think about the current function of immunity evolved throughout the ages?
Well, as an aging immunologist myself, I'm convinced that the immune system is very, very old, probably well over 1 billion years. And I say that in part because immunologists have studied the immune system of many different organisms on the planet. And essentially everybody has an immune system. And there are lots of common themes, so you can sense that the immune system evolved from a few original functions that then were multiplied and complicated over evolutionary time. And for example, single cell organisms have to defend themselves against parasites and particularly viruses. So I think the immune system that we have today is the result of an arms race over this very long period of time between us defending ourselves and viruses trying to come up with tricks to overcome our immune system and multiply in us, and we didn't like that. So it's a very, very old story, and I think it's kept us alive for a very long time, which I'm very proud of.
How does the immunity change as we humans age from children to the old person?
Yeah, so the immune system really changes over time. So in a newborn baby, the immune system is fairly immature. It will take several years to fully become functional. And then, many decades later, the immune system starts to change again. The phenomenon of immune senescence is one of the immune system declining. For example, telomeres get short. Immune cells won't have the ability to multiply and ramp up a huge immune response the same way in an elderly person as it did in a young person. So that's been thought to be a mechanism involved in autoimmunity and other diseases. When the immune system doesn't respond properly, it might respond in ways that are more harmful than good. And I mean, it's well documented too that elderly people become more susceptible to viral infections because the immune system doesn't have the same vigor and rapidity. So aging is a very important factor to consider in pathology like rheumatoid arthritis, which usually presents fairly late in life.
In your research, what effect age play in the immunity towards the diseases?
Yes, I think those diseases that present late in life are often associated with the changes in immune function. So rheumatoid arthritis, for example, that's one of the diseases I study, usually presents in the 5th or 6th decade of life, when the immune system is starting to decline. And on top of that, you have the very interesting phenomenon of, in these patients, the immune system is older than the rest of the patient is, presumably because the immune system has ramped up and lots of proliferation, lots of telomere shortening, so that in the end the immune system looks like the immune system from an older person than when the patient is. And I have to say also, when you age, you become a better immunologist too.